Creating simple HTML games is a great way to get into programming. But while many YouTube coding tutorials focus just on the coding aspect, there's a lot more to writing production code than simply the code. Automation testing makes sure that your code works not only now, but also in the future, because it's far too easy to break something without realizing. In this video, we'll walk through how to recreate Wordle, the New York Times online game, in Angular 15 using testing software along the way. We'll avoid using the keyboard and mouse for the majority of our testing, and will instead focus on proving that our code works with well-defined test cases. For the automation testing, we'll use Cypress, which is a great environment for automating any of your web projects. Now, while Angular focuses on component-driven development, we need some help with that, and so we'll use Storybook. Storybook is a handy utility for promoting component-driven development by providing a harness for interacting with your component and ignoring the other parts of your application. The components we're going to build are the virtual keyboard. This is what our user will use to type in their guesses, and it will also display some hints as to what letters the player has tried. We'll also use the game grid and the game cell. Now, the game grid represents the guesses that the player has tried, and the game grid will host 30 grid cells. And finally, to tie it together, we'll create the full game, which will house both the keyboard and the game grid. We'll start from the very beginning with only Node.js installed. So let's go. Before we can start writing code, we need to install a couple of global dependencies. So we'll install the Angular CLI and the Storybook CLI, and then we'll use ng-new to create our project. Now we're going to use skip install because we don't want to use npm for this, we want to use yarn. So after setting a few git properties, we can then call yarn and it will install all of our dependencies for the Angular app. Let's make sure we check in the yarn log file, and then we'll run ng-serve to see if everything worked correctly. And we should see the standard template Angular project at localhost 4200. There we go, that looks good. So the next thing we want to do is set up Storybook. So npx storybook init, and this will attach Storybook to our Angular project. Install a couple of dependencies, and then as always make sure we check in along the way. So we'll start running Storybook. This will be at localhost 6006. Now Storybook comes with a couple of built-in components just to demonstrate how Storybook actually works. So we've got a button, a header, a page, and we can see at the bottom we've got some controls or arguments, so we can start changing and interacting with our component, and we'll use all of these features in the Wordle project throughout the video. Now that we've confirmed that Storybook works, we'll set up Cypress. So ng-e2e will set up our Cypress project, and it will install a couple of dependencies that are required for Cypress. Now on your PC this may take some time. Before we can actually run Cypress, we of course need to make sure we check in, but there's a couple of configuration options that we need to change just to make this work with our Storybook and Angular setup. So we'll add the Cypress Storybook dependency, and then if we open up our config file, we want to change our base URL to our Storybook URL, not to our Angular URL, and we want to make sure that we create a support file, so Cypress support index. Now we actually want to add the file as well, because there's a couple of imports we need to add to this. So at the top, we want to make sure that we import Cypress Storybook, and then we also want to add the Cypress HMR restarter. Now this will make sure that when we change our code, the Cypress tests will restart automatically, and that's very helpful in test-driven development. Now in our preview.js and Storybook, we then also want to add Cypress files in here. This makes sure that Storybook, Cypress and Angular, they all work together. So if we open up Cypress now, it will ask us if we want end-to-end or component. We'll pick end-to-end. We'll choose Chrome for the purpose of our testing, and then it will open up a new Chrome window in automation mode, and it comes with a single test file. Because we edited our config file, the out-of-the-box test doesn't work anymore, but it's easy to fix. So we'll head to our E2E file for the initial test, and we'll change visit to visit storybook. So we'll load the correct storybook location, and then after this we'll load a particular story. So let's just load the example button that comes with the storybook. So we've now got a test. It displays our button in the middle, and I think that's it for getting Cypress and Storybook set up. To get this ready for coding, we're going to remove some of the samples that get added with Storybook and Cypress, and we're ready to start programming our project now. We'll use NGGC virtual keyboard to create our component. Angular will create 4 standard files. But in order to add this to Storybook, we need to add an additional file, which is virtual keyboard component stories ts. Now this file contains 3 standard components. It will be the metadata, which will define what our component actually is that Storybook needs to use. Now the first time we do this, we're going to have to manually type the import because VS Code isn't able to find it, but in the future it will. So during our metadata, we need to specify a title, a component, and our decorators. We'll go into more detail later as to what these actually are. Now, in addition to our meta, we then need to define our template. Our template effectively wires up our arguments and the component itself. And then finally, we need to define the actual story itself. Make sure we supply the export keyword so Storybook is able to find it. And if we save that and then refresh, we should see our story in Storybook. In order for our component to appear in Cypress, we need to add our Cypress testing file. So this is virtual keyboard cy.ts. And from here, we're going to describe our tests, and we'll call them virtual keyboard tests. So before any test runs, we want to make sure that we can visit Storybook. And this will just simply tell Cypress that we want to go to the Storybook URL. We want to set our viewport to iPhone 8 because we're developing this in mobile first. And then we want to load our story itself, our virtual keyboard empty story. We want to create our first test now, which is it should open in a blank state. And this will make sure that when the keyboard opens for the first time in a new game, none of the letters are pressed or have any state other than a blank white state. So let's switch to Cypress, and then we should be able to see this run. So we'll navigate to our new virtual keyboard Cypress file, and there we go, our component loads. Storybook and Cypress are ready to go now. So we can start editing the HTML to define a normal QWERTY keyboard. As with a normal keyboard, this will contain 3 rows. Now we're giving each row a class of row with an additional class of row 1, 2, and 3. We're also going to define the template for each button. We're not going to define each button here, but we'll do that in the back end. We'll define 3 arrays of letters, each representing a row on the keyboard. Now to use these in the component, what we'll do is we'll create an interface which will represent each letter. Because a letter contains more than just the string itself, it also needs to contain the state. So let's define the interface, and then we're going to recreate these 3 arrays further above by mapping the letter into the new interface. Back to the HTML, we're going to use an ng for loop, which is going to go through each letter in the row. And then within the element itself, we're going to output the letter so we can display it. So if we save that in Cypress, we can see that we've got our first row. We can then copy that all the way down through rows 2 and 3. And there we go, we've got all 3 rows of the keyboard. We're going to add a key class into each of the letters so we can then style it later. And just a quick save. And now we'll move over to the CSS. So in the CSS, the first thing we want to do is change our row, and we'll use a display flex Now this will make sure that each letter is then displayed on the same line. Now we can adjust some simple margins, and the next thing is the user select. By setting this to none, we can ensure that if a user is dragging over the mouse, they won't accidentally select and highlight the text in the keys. Onto the key class, we'll set a margin and some padding, and then a few other things like text align and borders, just so our key is looking a bit more like what we would expect. We can adjust the width of each key so it fills out the screen a bit more. And then when we're happy with that, we can then go back and adjust the alignment of the entire keyboard. It needs to center slightly, so we're going to use a display of grid. All the keys look aligned now. Just to round it off, we need to add two more special keys. These are the Enter and the Delete key that would appear in the bottom row of the keyboard. Now these are similar to the normal keys, except they are much wider, so we'll add a special class to each of these. Now clearly the width is slightly wrong, so what we'll do is go back to our CSS, and if the key is not a special key, then we'll specify its width. If it is a special key, then it will just simply ignore this property. Now the keyboard is looking a bit wide now, so I think if we can lower the width or the font slightly, we can probably get it to the right size. So just a bit of trial and error. Okay, that looks great. By default, Storybook will place all of our components at the top of the screen, but if we use the layout parameter, we can move it to the center. Our first test will count the number of empty rows. So first we'll use the CSS selector for the row class, and we'll check that there are 3 instances of the row class. Now we'll just switch back to 2, and the test should fail. And we'll put it back to 3. We're going to add some placeholders now for some pending tests. These are tests that we're not quite ready to complete yet, but by adding them into Cypress, we've got a good idea what we're aiming for. So these tests will check all the different states of the keys, and we'll mark them all as skip tests, so they're ready to go, but Cypress will show them, but it won't actually run them. To make our keyboard more useful, we're going to add some properties. So we'll add the answer property, and then we're going to add the guesses property. Now, these 2 properties are going to be used to make sure that the keyboard can change state depending on how the game is being played. So if you're a Wordle player, you'll know that if you correctly guess a letter, then the key will go green, or if you have a letter that you've guessed correctly but it's in the wrong place, then it will go yellow. And these 2 properties, answer and guesses, will make sure that we can track these states. We're using get and set properties instead of fields so that we can run code when the values change. Because what we need to do is update the key states if the guesses or the answer change, so we can recalculate what color or CSS class we need to display for each of the letters on the keyboard. So we're going to make ourselves a new function called recalculate keys. And what this will do is set all the states of the keys every time the guess or the answer changes, to make sure that we're displaying the right classes. In order to track the state of each key, we need to add a match property to the interface. Now this will either be a value of exact, partial, or miss, and that will determine the actual key state itself. So every key will start off with a null, but then as our guesses increase, we'll then start to set the states of each of these keys. So in the recalculate keys method, the first thing we'll do is join all the arrays together of the rows, so we have one single array of each key, and we can use that further in the method to control each of the states. Every time this function runs, we'll reset the state of each key back to null. and then we'll loop through each of our guesses so we can match the guess against the answer to determine what state each key needs to be in. The easiest way I've found to do this is to go through each letter and then match the position of the letter against the position of the answer, and if they match exactly, then the state of the key is exact. If they match but not in the same order, then the state is a partial match, and if they don't match at all, then it must be a miss. We'll transition into Storybook now, where we need to expose the answer and the guess arguments. Now, because guess is an array of string and not a string itself, it's easier if we make a new Storybook only argument called guess text. Now, in the Storybook metadata, we'll define both of our arguments. We need the answer argument and also the guess text argument. Now, the guess text argument is going to be, of course, a control of text, and we'll give it a default value of empty string. And then we'll also add the answer argument, which also is text with a default value. Now, in our template setup code, what we need to do now is before the guess argument gets passed into the control itself, we need to split up the string by commas and then convert it into an array, which will then be passed straight into the component. So the answer and the guess text argument have now appeared in Storybook, but as we start typing, nothing seems to be changing just yet. We need to add some CSS classes to determine the different states. So we'll use the match property and then add CSS classes for exact, partial, and miss. So we'll add these as nested classes inside the key class. So for exact, we'll give it a background of light green. For partial, we'll go with a yellow. And then for miss, we'll use a grey background. Our classes have started to work on the first row, so what we need to do now is just copy the CSS classes that we added onto the first row into the other rows of our keyboard. Now we can see that the letters aren't changing state exactly as we would expect, so to help with debugging, what we'll do is we'll add an extra class onto each letter, which will be the used class, so we can differentiate between a matched and a used letter. And just looking through some of the code, the states seem to look fine, and the classes are all lined up. So what we'll do is we'll nip into the debugging window in Chrome to try and work out what's going on. So if we then inspect each of the letters, we can see, okay, it looks like we've got a slightly different case. So we have a capital H of the letter. However, the answers and the guesses are all lowercase. Okay, so that's a pretty easy fix. So what we'll do on the answer is whenever we set an answer, we'll just make sure that we always convert it to uppercase. Back into Storybook, we can just adjust the argument slightly just to try a few more answers. So let's try a different word. Okay, that seems to be working exactly as we would expect. Now on the guesses themselves, just as with the answer, we'll convert each one of these to uppercase. This will just save us a few headaches in the future. Test that out with a few different cases. That seems to work pretty well. We can move back to Cypress now to start fleshing out the rest of our tests. So in the first test, we want to make sure that for a single guess, that all the letters match as expected. So we'll choose a different answer and a different guess. So we'll use hello world as our input values. And by saving as we go, we can see the states updating in real time. To make it easier for Cypress to now start to find that we are using the correct element, we want to add a special attribute, and we'll call this attribute CY_letter. Now this is separate from classes, and this is a non-standard attribute, but by applying this attribute for every single letter, it will make it much easier for us to find the particular element when using our Cypress test. So back in the test, we want to use a CY_get, and then using the square brackets, we want to find the CY_letter of L, and we want to check that this particular one exists, and there we go. So we want to specify a bit more the exact classes that we're expecting. So in the case of the letter L, we want to make sure it's a key and it's used and it's exact. Now we will repeat this for all other letters of the world guess and make sure that the classes match exactly what we would expect them to do. So of course for W, we've got the miss, then we've got a partial, then we've got another miss, we've got an exact, and we've got a miss. To round out the rest of this test, we want to count the number of letters that haven't been used. So using the selectors, we'll find all keys that are not used, and we want to check the length of these. And we'll set this to 23 because of course we need to make sure that we're also including the enter and the delete keys in this. That completes the first test, so we'll now move on to the next test, which will check for multiple guesses. So we'll use the same answer, hello, but this time we'll add a number of guesses. Now we need to separate these by comma, although these are not an array because it's a full string, so let me just fix that. And then if we save, we should see that the letters update. Given that we validated in the previous test the individual letters, all I'm going to do now is just have a bit of a broad test that counts the number of exact matches and missed matches. So of course we've got 4 exact matches, and then for the missed matches we've got 6. We don't have any partial matches in this test, but I'm okay with that. As a bit of a backstop, we'll just add the unused letter count, which instead of 23, this time it will be 18. Again, we need to account for the enter or the delete keys. So we'll remove the only attribute from that test, and now we'll move on to the final test. Now this one's a bit different because we need to check for the emitting of the events on the key press. Now we haven't added this yet, so we'll first add an output property to our component, which will emit whenever a key has been pressed. And although we're saying pressed, what we really mean is when the key itself has been clicked. So we'll make a new event emitter of string, and then we'll create a small function which will be on key pressed, and this will just fire that event. We'll use a VS Code trick here to highlight all 3 rows, and then on the click handler we'll call the onKeyPressed method with the desired letter. In order to capture the keyPressed event from within Cypress, we need to first add an action to Storybook. An action is similar to an event whereby we can view inside Storybook whenever an action has been called. So we've added the key action, which we've mapped to the key pressed output parameter. And now by clicking on each key inside Storybook with our mouse, we can see the key action is being fired. We'll then add the action to the delete and the enter keys so we can route these through the same pipeline. So if we save and then we start clicking on those, we should start to see that work. There we go, that's enter and then delete. Okay, perfect, that seems to work quite well. So heading back to Cypress on our final test, we can now start validating that our keys are being emitted. So again, using the attribute for the particular letter that we're interested in, we're going to see if we can click the element. So with square brackets, we've got the CY letter attribute. And we'll get the L key and then we'll click it. Now clicking it is only half the battle. We need to check that it was actually emitted correctly. So we've got a story action function that we can call where we can check for the key action and we can see whether or not it's been called. So we clicked the L and then we checked to see whether it was called, which it was. Now just to make our life a bit easier, we're going to make a small shortcut function called press key, which will take a letter and it will find the appropriate element with the CY attribute of the letter we want to click, and then we'll click it. And then we'll just call that a few times to simulate a word. So we will simulate pressing the letters for hello followed by the enter and the delete. And then we need to validate a few times that those were all called in the right order. Now the enter failed slightly because we don't actually have the attribute, the CY letter attribute for the enter. Now the reason we haven't put this one into square brackets is because we're not using a variable from inside Angular to be able to do this. We're actually able to hard code the value in so we can type it directly. So our test is working now, that's looking pretty good. Within Cypress, we want to check whether or not the call count is what we expect. So we've clicked the keys 7 times. So we want to check that the key action's been called 7 times, which it has. And now just for extra checks, we'll go through each of the letters that we expect and we'll check that the key action was fired with the value of the corresponding letter. We'll add a negative check as well to make sure that the letter K wasn't called. And this rounds off our test. Just one quick sanity check to make sure that all of our tests are passing, which they do. And then the final thing is just to check in the code. So that completes our first component. We've got some tests that check all the different states, and we can now move on to the next one. As with the keyboard, we're going to use ngGC to create the grid cell, and also to add the storyboard, we'll make the grid cell component stories file. It's the same process as before. We need to define the metadata, the template, and the story. This will help Storybook use the component, and then we can play around with the controls. So we'll set a title, we'll set a component, we'll set our empty decorators, but we will use these in a future component. Again, for our template, we will use the template to wire up the arguments for each individual story into the component itself. This is mostly boilerplate, nothing really changes between each story. Now we will add our empty story, simply bind it to the template, save, and we can see our grid cell in Storybook. So the first thing to do is to start editing our code. We're going to add a few input properties. We need the letter, which is the letter that will be displayed inside the grid cell. And then we're going to add the match, which is the state of this particular grid cell. As with the keyboard, it's going to be a partial, an exact, a miss, or null. Now, given that we've used the same code in the keyboard, it makes sense to extract this type into its own file. So we'll create a letter match TS file and we'll declare our type in here. And then we'll head back into the keyboard where we can reuse the same code. Into the HTML now, we're going to just simply display the letter property that is applied in the TypeScript. And then we're going to define our states, which are all defined as CSS classes. So using the host binding decorator, we're going to add classes for all the different states, which of course are, has it been used? Is it an exact match? Is it a partial match? Or is it a mismatch? And at the end, we're also going to add another property for the display value. Now this will sanitize the input to make sure that we're at least displaying empty string, if nothing else. And if for whatever reason the letter contains more than one character, that we're only going to display that first character and also make sure that it's displayed as uppercase. We'll adjust the HTML to now use the display value property instead of the letter. And then we'll start adding these arguments to Storybook. So we need to declare our argument types. And the first one will be the letter. Now this will be a text control and we'll give it a default value of empty string. And now if we test that out in Storybook, we can see that if we enter values into the letter argument, they display as we would expect. We can start adjusting the CSS now for our grid cell. So in the host selector, we'll change the display to grid. We'll give it a width and a height of 2em. And then we'll focus on the font size. Just a quick test in Storybook. And then we'll set our border. Now we'll see that it's not quite centered, so we just change the justify content and the align items properties, and that centers the letter. Now we need to work on the different match states. Of course, that's exact, partial, and miss. So first, using the used CSS class, we'll set the background color to gray, and then we'll override that for either the exact or the partial. So for exact, we'll use light green again, and then for the partial, we'll use yellow. It's time now to add the match argument into Storybook so we can start adjusting the different states. So this is going to be a select type, and we need to give it the different type of options that we have, which of course are exact, partial, miss, and null. Null will be for a cell that hasn't been used yet, and we'll set the default value to null. So we'll see in Storybook now we have a drop down, and if we keep changing it, we notice that our CSS classes are changing and this is behaving as we would expect. So we can move over to Cypress now and start filling in our tests. So we're going to make ourselves a grid cell CY file, and we'll describe our tests as the grid cell tests. Now, of course, we don't have any tests at this point, but before each test is run, we want to make sure that we load or visit Storybook, that we set our viewport to iPhone 8, and that we load the story that we're interested in, which in this case will be the grid cell empty story. The first test, we're going to check that the cell has loaded in a blank state. Now it helps here if we can just change the layout in Storybook to centered. So to test that the cell is blank, what we want to do is extract the letter. To make this easier, as with the keyboard, we used custom attributes, so we're going to use a CY letter attribute, and we're going to extract the letter from the property and just return it in the attribute. And then from within Cypress, we can then extract the element using the attribute. And the first thing we want to check is, of course, that it exists and that the value of the attribute itself is blank. To double check that this is in fact a blank cell, we want to make sure that it doesn't have the used class. This would be associated with any kind of match. And now on to the next test. So we want to split up our tests into two categories. We've got our pending tests, which is when a grid cell is used for a guess that hasn't yet been submitted. And then we've got our committed tests. There's only going to be one pending test, and that's to make sure that it has a letter. And then for the committed tests, we've got three tests that we want to check. So we want to make sure that it either has no match, i.e. the letter doesn't match. There's a partial match, which is the letter exists but not in the right place. And then we have an exact match. So we've created all those. Now, in the meantime, let's just mark them all as skip because we're not ready to fill them in yet. For the pending test, we want to mark it as only. So this is the only test that we're going to run. And then we're going to extract the properties that match. But first, we're going to set the letter to B. Now, we don't need a match argument at this point because this is a pending cell. So we want to extract the element using the CY letter attribute. Of course, making sure that it exists and that the value of the attribute matches the letter B. In addition to checking the attribute, we also want to make sure that any of the classes that we don't expect to be there are not there. So for example, the used class. Just as a bit of safety, we're going to set the match to null. I don't think we need this because it's the default value, but it doesn't hurt to add it. So we can move on to our committed test now. So to help with each particular test, given that they generally check for the same thing, we want to add an after each function which will check that the used class has been added onto each test case. So this is just going to save us some time for each particular test. Now for the first test in the committed section, we want to of course set the argument. So we'll set the letter to C this time. And then we'll change our match to a miss. So the checks that we want to perform at this point is to extract the letter and make sure that it matches the C that we specified in our argument. We also want to make sure that it has the miss class in addition to the use class, and that pretty much does it. Now for the other test, it's pretty similar, almost identical in fact, but we're going to be checking for the different classes that match up with the states that we expect. Now that about does it for all of the tests for the grid cell. So we just want to make sure that our virtual keyboard tests also pass, and they still do. So we can now go and commit our code for the grid cell and move on to the next component. For the game grid component, it's the same routine, ng-gc game grid, and then again we'll make the storybook component. So again, rinse and repeat, it's the metadata, it's the template, and it's the stories. And then if we save, we should see that inside Storybook. We'll make sure that we set our layout to centered and then start adjusting our HTML. So the game grid itself is broken into three sections. They're all rows, but they're rows depending on which different state of the game we're interested in. So we've got the empty rows, the current guess, and the guesses. So to understand how many empty rows we currently need, we're going to create a property called number of empty rows. And for now, we'll just return 5, but this will change. And then we'll define our row, which will be row and then row of class empty. And then we'll loop over the number of empty rows that we previously defined in our property, which of course is 5 at the moment. And then we want to add 5 grid cells from our other component. Now this isn't appearing in Storybook, and this goes down to the decorators that we've touched on in the previous components. So what we need to do is tell Storybook about the grid cell component. So inside our module metadata, in our declarations, we also want to include our grid cell. As we save that now, we can see our empty rows will appear. And we just need to adjust the CSS now so it looks a bit more like a grid. So we'll make the row a flex box with a small gap, and then the actual game grid itself, through the host selector, will turn that into a grid with a gap of 0.3 em throughout. We'll now start to flesh out the current guess. The current guess is what the user is going to be typing in at the time. So again, that's a row, and we'll give that a class of current. And then we'll just copy in the grid cells, so now we have a grid of 6 rows. We need to start defining some properties now inside the Angular code. So we'll set the current guess. Now we'll make this a get and a set property, so we can manipulate some of the code in real time if we need to. So we'll declare our private current guess backing field, and then we'll just set that here. Now what we want to do is make a method which allows us to extract the letter based on the correct index. Because each cell needs a particular letter, it's just helpful to have these methods. And then we'll add the current guess as an argument so we can start playing around with it in Storybook. So this is another control of text with a default value of empty string. And back into the HTML, we want to then wire up each of the cells with the index of the current guess. So we're going to use a VS Code trick here to highlight and edit multiple rows at a time. So we'll set the letter property of the grid cell, we'll call the method that we just created, and then we'll fill in the indexes 0 through 4. And to test this out, we can start typing in Storybook, and we can see that our current guess is appearing in the top row. We can fill out the other properties now, for example the answer and the guesses. We need to make sure that at all times we convert as much as we can to uppercase. That's definitely going to help us in the future. And with the guesses, we want to make sure that there's no more than 6. Now to help with the guesses, especially with Storybook, because it doesn't really handle arrays very well, is we're going to use our string to string array trick that we used in the keyboard. So bringing in the extra args, and we're going to split the guess text by comma. So whatever we type into Storybook can be converted into an array so it can be used inside our grid. We need to flesh out the guesses. So of course each row contains 5 cells. And now we're going to take a copy of the letter of current guess method and use something similar for the previous guesses. So we'll work in almost the same way, but this time we'll also pass in the guess as well as the index of the letter that we're interested in finding. So with the quick test now in Storybook, we've got the commas between the guesses so we can try multiple different guesses. And we can see that it seems to be working pretty well. A new guess row is created every time. But of course we now want to adjust the number of rows that we have based on how many guesses have actually been entered. So we'll update the number of empty rows property to return the correct number of empty rows based on the number of guesses. Now this is going to be a range between 0 and 5. We of course have 6 rows in total, but we reserve 1 for the current guess. Back in Storybook, we need to add the answer argument so we can start applying some of those CSS classes that we've used previously. So again, this is a text control, very straightforward, with a default value of blank. In order to apply the correct state for each cell in the grid, we want to create a function called match for letter, which will take the guess, will take the index, and it will make sure that the guess letter matches with the answer letter. So the first thing we need to do is check that the actual letter itself matches in the right place, and that of course is an exact match. Or if the letter is found somewhere in the answer, then it's a partial match. Or if it doesn't match at all, then it's a miss. So we'll use some VS Code tricks now to apply that new match property using the match for letter function that we just used. And then we can test it in Storybook and see if it works. So it feels like we've nearly finished with this game grid. We can enter the guesses, we can see that they're filling in correctly. I think there's just a small bit of cleanup that we need to do, and then we can commit this. A small thing is, if we've currently exceeded the maximum number of guesses, then we don't need to show the current guess row. So that's a very simple property that we can create, and then we'll apply it with an ng if on the current guess. So what we should be able to prove is if we've already got 6 guesses, then the current row will disappear. So that means the game grid will never exceed 6 rows, no matter what state it's in. Switching back to Cypress, we'll now need to create our tests. So we're going to create a game grid CY file, and as before, we'll describe our tests. Before each test, of course, we need to visit Storybook, we need to set the viewport to iPhone 8, and we need to load our game grid empty story. So let's fill in our 5 tests that we're going to need for the game grid. These are going to cover all of the states that we expect in the game grid. Now we're going to mark them all as skip because we're not yet ready to fill them out. But the first one, of course, testing that the grid is blank. We want to check, of course, that we have 30 cells with no letters in them, and that we have 6 rows. For the next test, we want to make sure that there is a single guess. Now, given that in the previous components we've thoroughly tested everything, we only really need to do surface tests for this. So we're going to set an answer to hello, and then we're going to set the current guess to a different word, which will be world. And now at this point there are no matches because we haven't submitted the guess. So we just want to make sure that this is behaving exactly as we would expect. Now, doing something different here with Cypress, we want to use the within function. So within the current row, let's extract all of the elements that contain the CY attribute, and then using the CY letter attribute, we can then match each of the letters individually. Now, what's a bit strange here is that we're looking for a capital W, but actually what's happening is we've got a lowercase. Even though in a few places throughout the project we have done a to upper conversion, I think we probably need to go back later in the project to make sure that we do that throughout. But either way, let's check all 5 letters in this particular row and make sure that it matches exactly what we expect. As a few additional checks within this test, we want to make sure, of course, that we have 5 empty rows underneath the current guess. And also, given that this is the current guess and also the first guess, we want to make sure that there aren't any other guesses above this particular current one. So we're going to be having a single current row, 5 empty rows, and 0 guess rows. The next test for the game grid is we want to make sure that we have an existing guess above the current guess. So of course we're going to set the argument. We're going to set another argument for the guesses that have already been made, and we'll use the version here where we can pass in the comma. We're also going to specify a current guess which will go below the first guess. We can borrow the code from the previous test to make sure we have the right number of rows. Of course, we should have a single guess row, a single current row, and now only 4 empty rows. And then we can go through and validate the individual letters of each of the guess row to make sure it matches with what we expect. Now, the final 2 tests with this particular control will either check what happens if we have too many guesses, i.e. we've exceeded the 6 guesses that are allowed without there being a match. And then finally, the test at the end will check what happens if we do have a match. And in that case, we want to make sure that it isn't possible for the user to enter anything further once we have successfully detected a match. Now, there's a final place that we missed where we want to make sure that we're always converting the strings into uppercase, so we'll do that now. Now, I expect one of the tests is going to fail now, which is fine, so we can go back and correct that mistake by ensuring that in all places where we're looking for a letter, it's always uppercase and not lowercase. So all of our tests are passing now. So we can commit the code and move on to the final component. For the final component, we're just going to zip through the setup time, ngGC full game. The point of this component is to house all of the other components that we've created. As before, we're going to create our storybook. We need to make sure that we declare the other components that we've created because Storybook needs to be able to find them. We'll set up the template, we'll set up the story, and then we'll get into assembling the component. This component is significantly more easier than the other components that we've created. We want to create a simple title using a H2, we want to add in our game grid, and then we want to add in our virtual keyboard. Now there's a couple of alignment issues here, so they should be pretty simple to fix. So we'll head into the CSS, and then in the host element we'll change our display to grid. And then we'll make sure that everything is centered and add a simple gap. Now the H2 itself by default has text align of left, so we can adjust that with just changing the text align to center for the H2, and that should fix our layout. We need to define a few properties as we usually do for our component, so we need our answer property. We're also going to be adding in our guesses. Even though these will generally be generated by the component itself, they'll be useful for testing. So we can wire up our answer. We want to use the same answer for both the grid and the keyboard. And then let's make sure we wire up the properties to the backing fields. We're creating our guesses property right now. We also want to create a simple private property for the current guess. This is going to be the guess that will be maintained by the game. Now in the storybook side, we want to use the same code that we used before for converting a string with a comma separation into the guesses array. So we'll add the arguments for guess, for the answer, and then we'll start testing this out. Make sure we pass in the correct guesses variables and a quick test. And it looks like our game grid is working quite well in the full component. It's now time to wire in the key presses. These could be virtual from either the on-screen keyboard, or they could be physical from an actual keyboard. We in the future need to handle the delete and enter. We'll come back to that. But the first thing we want to do is to add the incoming letter to the current guess. Now, just as a bit of safety, we'll make sure that we're only passing in the first letter of the guess. And then the new current guess field needs to be passed into the game grid so we can utilize that final row of the game grid. To extract the keys themselves, we want to handle the key pressed event that comes from the keyboard. We tested that earlier. And now inside Storybook, if we start pressing the keys, they are inputting them as the current guess. So we can now handle the enter and the delete states. So if the incoming letter is the word delete, then we want to remove a character from the current guess. And if the incoming letter is the word enter, we want to commit the guess. So for handling the delete key, we're going to take the current guess. Now first we want to make sure that the current guess contains at least one character, and if it does, then we'll use a simple substring method to chop off the final character from the guess. So just give that a quick test. And now for submitting an answer, what we want to do is to take the current guess, we want to add that to the array of guesses, and then we want to clear out the current guess. As a quick bit of safety, we want to make sure that we only submit an answer if 5 letters have been typed in. And that completes our key handling code for normal letters, and then delete and also enter. So we should be able to test that in Storybook now, where we can enter a guess using the on-screen keyboard. Make sure we uncomment the code we commented out before. There we go, we're now entering the text. And then we hit enter, and the match has been detected. So some small bit of logic that we want to add towards the end now is to check whether or not we've actually finished the game. And we define finishing the game as either entering too many matches or entering the correct match. So we'll just create a simple has finished property. And in the key press code, we'll check that particular property. So we'll make sure we ignore any key presses if we've actually finished the game. Now, it's not just the virtual keys that we need to handle, it's also the physical keys. So let's rename our key press method to virtual key press, and let's create a host listener for the actual key presses that somebody will physically type on a keyboard. So host listener will bind through Angular the key press into this particular method. Now for the physical key press, we want to check the same properties as for the virtual key press. So if we finish, then don't do anything. If the enter key was pressed, then submit the answer. If the backspace was pressed, then we want to decrement a character from the current guess. And if it was anything else, then we'll just add it to the current guess. Given that we want to type into this through Cypress, we want to make sure that we expose the tab index property. So we'll just set that to 1. It's now time for our final test. So we want to create our full game Cypress file. We want to describe our tests as usual. Before each test, we want to visit Storybook, set the viewport, and load the story. And then we'll define our tests. So we want to make sure that the game loads correctly. We want to make sure that we can receive the keys either typed or clicked. We want to see what happens if we have the wrong answer, if we have the right answer, and if when the game is finished that we don't have any input. So let's whiz through the creation of all of these tests. It's the same principle as all the other components, where we want to make sure that all of the states that we're expecting are working. So for example, does it load with a blank game? If we are receiving our keys, are they being accepted correctly? What happens if we have an invalid answer? Are the cells appearing in the way that we would expect? And this is just proving that our game is working exactly as we would expect. It doesn't hurt at this point to look at our other test files and make sure that everything else is passing exactly as we expect and we haven't broken anything along the way. So that's the game grid, then the grid cell, and then finally the virtual keyboard. As before, we now need to make sure that we can commit our code. So let's check in the full game component. And then we're going to run Cypress now in a totally different mode by calling yarn cypress run. What will happen is Cypress in the background will find all of our test files and will run them through without actually opening up a browser window. This is really great for a CI system, so you can make sure that your tests still pass after a coding session. And what you'll also see is Cypress has extracted videos of the tests that it's performed. So you could save these for a backup server. And so if anything is broken during your tests, you've got an actual history and evidence of what was really running and what potentially has broken. Now, it's generally good practice not to check these in if you're running them locally, and that's okay. So we'll add in the videos directory to the git ignore file, and that will just remove them from our source control, and we'll just check that in. So all that's left to do is actually run the game for the first time in the normal Angular environment. So ngserve will boot the standard Angular development server, and then we'll switch to localhost 4200. Now, of course, because we've been developing in Storybook all this time, we actually need to make sure that we import our standard game component. So from the app component code, which is your main entry point for your application, let's bring in the app full game, and there we go. We've now got a full Angular application that's fully tested in Cypress, every component, with a keyboard and the game grid, and we're able to play Wordle. Of course, with this version of Wordle, you need to actually hardcode the answer, which isn't particularly useful, but it's clear to see how you could modify your code to use auto-generated answers or pull them from a server or whatever it is that you'd like to do. This is where we're going to stop the video for now. Of course, it's not a complete game as the answer is hard-coded, but it's a great starting point if you want to make your own version of Wordle. All of the code is available on GitHub, link in the description, and I'll be posting some articles on my blog and maybe some follow-up videos which dive deep into some of the concepts that we've discussed here. Thank you for making it to the end of this tutorial. Don't forget to like and subscribe, and I'll see you in the next one.